In this video, we're going to use the idea of slope to prove whether or not lines are parallel or perpendicular. So the first thing we want to make sure we know and understand are what are parallel and perpendicular lines. So parallel lines are displayed right here. Parallel lines are a set of lines, whether it's two or more, that will continue to go in the same direction and never ever touch, which means these will never share a common point. Doesn't matter how long the lines are, it's just whether or not they're going to touch. Perpendicular lines are two lines that not only cross, but when they cross, they form a set of 90-degree angles, so right angles. Lines that are not parallel and not perpendicular, which are the two special cases, don't really have a name. They're just called intersecting lines in this case. So no right angles, and they clearly cross, which means they can't be parallel. For the purpose of this lesson, we're going to focus specifically on our parallel lines and our perpendicular lines. So let's talk about parallel lines. So parallel lines, as mentioned before, are lines that'll never touch. So these are parallel, and we're going to use the idea of slope to prove why they're parallel. So if you recall from algebra, the way that you can find slope when you have a graph is by doing rise over run. Rise doesn't always mean rise. It's either going up or down. But run, we're always going to try to get in the habit of running to the right. Whenever your line is going up, what I do is make the triangle like this on top because it's going up and I want to know that it's positive. If it was going down, we make the triangle at the bottom. So to find the slope, we're going to do it this way. So we want to count how many boxes or how many bubbles we're going up. So this is +2. And then since we're going over, I put a dash for like a division sign. We're going over 1, 2, 3, 4. So this would be +2 over 4. Because we're running, it's always going to be positive. If you look at this number, you can actually simplify it though. 2 over 4 is the same thing as having 1/2. So this would be my final slope, but this number isn't wrong. So we're going to do the same thing with line B. So rise over run. So again, we are going up. This is +2, and we're going over 1, 2, 3, 4. Looky there, we have +2 over 4. And notice that you have the same slope in this situation. So this could be a complete coincidence that these parallel lines are giving us the same slope. I don't really like coincidences. I like knowing that something is actually true and can be proven to be correct every single time. So let's look at the second example and see, does this same slope thing have anything to do with parallel lines? So let's say this is number 1. Let's say this is number 2. All right, so for line C, we're going to do the same thing. If you look at this line, you see that it's actually going down. So since it's going down, I'm going to make the triangle underneath. So this is down, so that's a -2, and it's over 2. So the slope of this would be -2 over 2. If you were to simplify that, 2 goes into both 2 and 2, obviously, so -1 over 1, which is the same thing as -1. That's the slope of line C. Line D, do the same thing. This is negative, so it's going down, -1 over 1. So this is -1 over 1, which, as we already said, simplifies to give us a -1. So we're seeing that this is not a coincidence. It's not a coincidence that when you have parallel lines, your two lines are going to have the exact same slope. So that's the thing to remember. Parallel lines are going to give you the same slope every time. But when I say same, I don't mean like a person has 50 cents and the other person has 51 cents. Like they're really close, but they're not the same. No, when I say same, I mean like the exact same number. So when you're simplifying it, just make sure you're careful. You look at the final number and it should give you what you need. So key point number 1, parallel lines have the same slope. Let's go to perpendicular lines and see how these are different. So perpendicular lines, we're seeing that they cross, but we want to see if they make a 90-degree angle. It's kind of hard to tell. I mean, unless you have a protractor, you can measure it, but we're telling you in this case that they're perpendicular, and let's see how the slopes relate to that. So with line A, I'm going to go ahead and create our triangle. This line is going down, so it's negative. So -1, 2, 3, 4, 5. So that's -5 over, we're going over 1, 2, 2. So this has a slope of -5 over 2. I'm going to write that down here so we can see the relationship in a second. And then line B. All right, so this is line B, so boom, boom. So this one's positive. So this one's actually a positive 2, and we're going over 1, 2, 3, 4, 5. So we see that this one's going to be pretty different, but there's also some similarities. So we're going to explore those similarities in this example. Give me 1 second. Erasing, got rid of all my work. So we said 2, 5. This is positive 2 divided by 5. All right, so let's see what's the same. Let's see what's different. So one thing that's different is the signs. So I see that this one's negative, this one's positive. So we know that the word negative is important. And when I say negative, I just mean opposite. So I'm going to write that in parentheses. So opposite. So when you have perpendicular lines, your signs are going to be opposite. And then the other thing you're going to see is that your number changed. So it flipped. It went from being, your 5 went from being at the top in the numerator to the denominator. So what we call that is a reciprocal. And what that means is that you're essentially just flipping your fraction. So whenever you have perpendicular lines, what's going to happen is you're going to have negative reciprocals, which means that your fraction flips and the sign changes. And let's see one more example of that. So for line A, going to do the same thing. So create a little slope. So we're going down 1 and over 1, 2, 3. So line A's slope is negative 1 over 3. So try to guess what line B's slope is going to be without even doing anything. Take a couple seconds. Okay, hopefully you have your number in your head. If not, let's see how we can get it. So these two share this point. So this one's going to go up 1, 2, 3. So it's a positive 3, and it's going to go over 1. So the slope of line B is positive 3 over 1. Notice that these numbers are flipped and the signs are opposite. Boom, that means perpendicular. So really quickly, you can actually simplify. 3 over 1 is the same thing as 3. This will be your final slope. But if you're given a whole number and you're like, I'm not exactly sure what's happening, remember that 3 is the same thing as 3 over 1. All right, so let's kind of sum this up. So we said earlier that there are 3 types of situations we're going to have. We're going to have parallel lines. Use color. So parallel lines, which are going to be lines that don't touch, and specifically about their slopes, parallel lines are going to have the same slope. Equal, numbers don't change, all of that. The second type of lines we're going to have are perpendicular lines. And what's going to happen with perpendicular lines, like we said, is that they're going to be negative reciprocals, which means opposite signs and flipped fractions. And lines that are neither, just nothing is the same, nothing special about them. Slopes are different and not negative reciprocals. Right, so that's the summary. So we got our summary, we know what parallel lines are, perpendicular lines are. Feel free to rewind this video as much as you want. Last thing we're gonna do is I'm gonna do a couple of examples with you, just so you can see how you can tell. I have 4, I'll do 2 or 3 with you. Then you'll be able to practice on your own. So let's try example 1. So in example 1, we don't have points. So sometimes that'll happen where you don't have points. So you just have to kind of look at it and figure out where the points would be. So I'm going to make a point right there. Let me do this in red because I've been doing A in red. So a point right there, and that's a point. And you want to make sure that the slope is the same. So if I keep going, you'll find that there are points across all of them. And I'll do the same thing with blue. So blue, there's a point right here. It's not right here, right here. All right, so for line A, I'm going to find the slope from, let's say, this point to this point. Cool thing about slopes is that if you've chosen the right points, it doesn't matter what set of points you go to. When you simplify it, it should give you the same thing. So line A's slope From here to here, we're going down, so it's -1, and we're going over 2. I already know these lines are not going to be parallel because they touch, but we just want to see if they're going to be perpendicular now. So this has a slope of -1 over 2. For this one, I'm going up 2, so that's +2, and then over 1. So that's +2 over 1. So remember the special thing about perpendicular lines is that they need to be negative, which means the signs change, and they need to be reciprocals, which means that the fractions are flipped, which they are in this case. So let me simplify this first. So we said this will be 2. So what we want to do is fill in the blank. So it says line A is it parallel or perpendicular? This is perpendicular to line B because the slopes are negative, which means opposite, reciprocals, which means that the fractions flipped. All right, one more. I'm going to do 2 with you, and then we are going to be done. All right, so the last one I'm going to do with you is this one. So they look like they're parallel, but we want to make sure that they are parallel. And I'll do one more with you because I want you to see in either situation. So first thing we want to do is create our triangles. So since this is going down, I'm creating it underneath. And this is -1, and if I count, that's 1, 2, 3, 4, 5, 6. So the slope of line A is -1 over 6. And then line B, this is also going down. It's -1, looking parallel so far. 1, 2, 3, 4, 5, 6, boom. These two lines have the exact same slope, which means that line A is parallel to line B because the slopes are the same. I hope y'all are catching what I'm dropping or picking up what I'm dropping and that this is making sense to you. Again, feel free to rewind if you need some more, if you need this to be to sink in a little more. Right, last one. So this one I'm already telling you is not going to work, and you're going to see exactly why it does not work. All right, so line A didn't do the best job with these points, but these are the only points that would work. So line A is going to be these 2 points. So we're going to count. So 1, 2, 3, 4, and this is going down, so -4. And then 1, 2, 3, 4, 5. So line A slope would be -4 over 5. And remember, if they're perpendicular, which they kind of look like they are, then these numbers should just be flipped and the signs change. All right, so now we're going to do it in this direction. So we're going to go up. So this is 1, 2, 3, 4, 5. Okay, so far it's looking good, and that's positive. So +5. If it's perpendicular, this number at the bottom should be 4. But it's not, which means that line A, these are not anything special. Line A is not perpendicular or parallel to line B because the slopes are different. And that means not the same and not negative reciprocals. If you understand this piece, then most of the quiz that you're going to work on should be a piece of cake. Right? Good luck.